Okay, dear students, now comes question number 22, and it is solving the linear differential equation given by dy over dx equals x squared into 1 minus 6y, where y at 0 is 1. So initial condition is given, so a specific solution or a particular solution is expected. So how are you going to do this? So simple. As we derived in our classroom, there is a specific formula. Using that, we can directly solve this as follows. So the solution runs like this. So dy over dx is equal to x squared into 1 minus 6y can be the same as this one, student. Look, dy over dx is basically equivalent to y prime, and equal sign comes as it is here, but x squared times 1 comes x squared. Let's now move this x squared minus 6y to the left. Okay, in this case it will be plus, right, 6x squared y. So look, students, this is now a linear expression written in terms of y prime plus p of x y is equal to f of x. Okay, so as you see, the standard form is like this: y prime plus p of x y is equal to f of x. So from this we have derived a certain formula, and that was y is equal to 1 over I, which is actually the integrating factor into the constant c plus the integral of f times I dx. Now, in order to know these parameters f and I, you have to know, you see, first the standard form. You have written in standard linear form, so the one written to the right side of this equality sign is considered to be your f. So in our case, f is going to be x squared, as you see, and the coefficient of y, which has been written as p of x, is treated to be your 6x squared in this particular example. So everything is forward, so we can directly apply the formula and determine the unknown values. Okay, so now let's determine, you see, what I is going to be the integrating factor. So as I said, the integrating factor I is obtained by using e the power of the integral of p of x dx, and we knew that p of x is 6x squared, so you directly put 6x squared in place of p of x here. So from this, e the power of the integral of 6x squared is 6x cubed over 3. So 6 divided by 3 makes 2. So you do have 2x cubed. So finally, the integrating factor is going to be e the power of 2x cubed. So this is just to say that if you multiply this non-exact differential equation by e the power of 2x cubed, it will be exact. So you can apply basically the exact formula after multiplying the given non-exact differential equation, the one written here, you see, by e the power of 2x cubed, and then you can solve using the exact formula. But basically, what I'm going to apply is the formula we derived in our classroom. Okay, is the formula we derived. So using that, I'm going to determine the solution for this one. Now copy this and paste here. The general solution, as you know, is given by the formula y is equal to 1 over I into c plus integral of f I dx. So we knew what I is. I is what, student? E over e the power of 2x cubed. So when you bring this 1 over e the power of 2x cubed, this e the power of 2x cubed can be taken up, being a minus. You see, having minus in its exponent. So this comes e the power of minus 2x cubed. Then you do have c here plus the integral of what is f, student? F is already taken to be x squared, so you simply put that here, x squared. Then your integrating factor I is obtained to be e the power of 2x cubed. Here it is, dx. Now everything is done. It's a matter of obtaining this integral expression. Okay, so how do you find this integral expression? Just you need to apply integration by substitution and by part, turn by turn. So for that, we are having here e the power of minus 2x cubed into c plus x squared e to x cubed dx. So now as we are applying integration by substitution, make 2x cubed to be u, as you see. So the derivative of u will be 3 times 2 makes 6x squared, as you see, 6x squared dx. So upon substitution of this one, where here the following can follow. This will be e the power of minus 2x cubed into c plus, now look here, students, what is 2x cubed? It is already u, so this will be e the power of u, as you see, e the power of u, and here x squared dx comes. What is x squared dx? X squared dx here is 1 over 6 times du, so let you take 1 over 6 out, and then e the power of u du can follow. And from this, the integration of this makes the following one. e is a power of minus 2x cubed into c plus 1 over 6 e is a power of u. We knew what u is because u is already determined. It is 2x cubed. So this will be e is a power of minus 2x cubed into c plus 1 over 6 e is a power of u is 2x cubed. Have that as it is. Now let's multiply this by e is a power of minus 2x cubed. In doing so, this can come. Y is equal to, look, this is a constant c, this c multiplied this one, and you do have this. So the bases are the same, e, so let you take 1e here and add the exponents, minus 2x cubed plus 2x cubed. It will be e to the power of 0, which actually is 1. So 1 times 1 over 6 is going to be 1 over 6. So as you see, this is going to be the general solution for this sort of differential equation, linear differential equation, in fact. Differential equation. Now, what is given? Initial condition is given. You have been told that at x0, y is 1. So let's substitute this one. Put 0 in x and 1 in y. And then you can solve for c. Then, using this initial condition, you can have this one, okay? When y is 1, look, x is 0. So everything is in its place. So the following can come. Look, this is what, students? 1, because e is a power of 0 is 1. 1 times c is c. As you see, 1 is equal to c plus 1 over 6 is going to come. And this is determined by 1 minus 1 over 6. You see, just move this 1 over 6 to the left. C is going to be 1 minus 1 over 6, which actually is 5 over 6. Now the value of c is determined. So we can directly put this c in our general solution over here. You see, so the particular solution is going to be y is equal to 5 over 6. As you see, c is just directly replaced here in place of what? C here in our general expression. So 5 over 6 is a power of minus 2x cubed plus 1 over 6 is a particular solution for this particular question. And proceeding to the next one, we have another one. You see, another question for you, and that is question number 23. It says solve the linear differential equation given by dy over dx is equal to 2 times sine x cos x minus y tan x, where y at 0 is 1. Students, this by itself is a linear one because it's written in terms, we can rewrite this in terms of linear form. How is that done? Let you see. The solution of this goes in this way. dy over dx 2 times sine x cos x minus y tan x can be written as, look, dy over dx can be written as y prime, and here 2 sine x cos x can be written as sine of 2x. Just apply trigonometric identity, and you can bring this minus y tan x to the left and it turns to be plus, and then y tan x can come here, so this is going to be sine 2x. Here we have, so y prime plus y tan x equals sine 2x. Look, student, this basically is written in terms of a linear standard form. So your p of x is taken to be tan x, and the one written to the right side of the inequality, that is sine 2x, is treated as your f of x. So look, students, p of x is tan x and f of x is sine 2x. So now I'm going to lead you to use the formula we wrote before, and that is the integrating factor is e to the power of integral px dx, and we knew what, you see, px is, it is tan x, and e is a power of, we know what tan x is, it is a ratio of sine and cosine, as you see. So let you use cosine x to be u. Here comes the step I did. If you let u to be cos x, look, student, du will be negative sine x dx. So in place of sine x dx, have this to be negative what, du. So just have negative out, and then du over u comes. And from this e is a power of, we know that minus is out, integral of 1 over u du is ln u. So from logarithm property, I can bring this minus 1 up, you see, as exponent of u, and it will be e is a power of ln of u is a power of minus 1, which actually is 1 over u. And we knew that logarithm to the base is here, so this expression simplifies to 1 over u. And we knew what u is. U is assumed to be cos x, so directly put cos x in place of u. Thus, I is obtained to be 1 over cos x, which actually is the same as sec x. Now, once you determine u, the next one is to write the general solution. The general solution is determined by this one. Remember, students, we derived this in our classroom. because by just applying the concept of exact differential equation, right? Using the formula we derived for exact, we have also derived this one for linear differential equation, if you remember. So now what comes here is y is equal to 1 over I into c plus integral of f I dx. So 1 over I is 1 over I. Where is I, student? Here it is, 1 over cos x. So 1 over cos x comes to be cos x, as you see. Then you do have a bracket being opened, then c comes here, plus what is the integral of f times I? We knew that f is, you see, sine 2x, and we know I is 1 over cos x. So as you are multiplying these two, sine 2x times 1 is sine 2x. Sine 2x over cos x can come. Here it is, sine 2x over cos x. So what is this? How are you going to find the integral of this one? So simple. As we did here, sine 2x is nothing but it is 2 times sine x cos x, as I used before. So sine 2x is 2 times, as you see, sine x cos x. And cos x, the one written as a denominator, comes as it is, as you see. Now we can cancel cos x by cos x, and then we can have integral of 2 sine x alone. And we knew that the integral of 2 sine x makes minus 2 cos x, as can be shown. Hence, what is obtained? The integral expression is now simplified to be minus 2 cos x. Thus, y equals to 1 over y I into c plus integral of f I dx is now determined. It is obtained to be cos x into c minus, look, this result is already done, 2 cos x. So the general solution is now determined. It is obtained to be y is equal to c times cos x. You see, c times cos x, you can multiply this with this, c cos x minus 2 times cos squared x, as you see. This is a general solution. In fact, had we not have this given condition, this would have been the final answer. But you see, initial condition is specified here, so we need to determine the particular solution. So we have to determine the value of c just by letting x to be 0 and y to be 1. So in doing so, the particular solution is going to come. You see, now put 1 in place of y, as you see. And here, in place of 0, in place of x, I mean, put 0. That c times cos 0 is going to follow. And here, minus 2 times cos squared 0 follows. And we knew that cosine 0 is 1, right? So this is going to be 1 equal to c times cosine 0 is already 1, minus 2 times cosine squared 0, which actually is 1 squared, 1. And from this, you can have 1 is equal to c minus 2. So the value of c is clearly 3. So dear students, c is now obtained. So where shall you put this c value? In your general solution. Here it is. You see, you are having c in your general solution. Now because of this initial condition, you are expecting particular solution. Here comes the particular solution. Just substitute this 3 where in place of c here, and then no more general solution. That will turn automatically to a particular solution. So the particular solution is going to be y is equal to 3 times cos x minus 2 times cos squared x. I hope you have understood the idea in a better way. Thank you.